to the Comptia Network Plus course. As you already know, routing is the process of getting your data from point A to point B. Routing datagrams is similar to driving a car. Before you drive off your destination, you determine which roads you will take to get there. And sometimes along the way, you may change your mind and alter your route. The IP portion of the TCP/IP protocol inserts its header into datagram, but before the datagram can begin its journey, IP determines whether it knows the destination. If it does know it, IP sends the datagram on its way. If it doesn't know and can't find out, IP sends the datagram to the host's default gateway. Each host on a TCP/IP network has a default gateway and off-ramp for datagrams not destined for the local network. They're going somewhere else, and the gateway's job is to forward them to that destination if it knows where it is. Each gateway has a defined set of routing tables that tell the gateway the route to specific destinations. Because gateways don't know the location of every IP address, they have their own gateways that act just like any TCP/IP host. In the event that the first gateway doesn't know the way to the destination, it forwards the datagram to its own gateway. This forwarding or routing continues until the datagram reaches its destination. The entire path to the destination is known as the route. Datagrams intended for the same destination may actually take different routes to get there. Many variables determine the route. For example, overloaded gateways may not respond in a timely manner or may simply refuse to route traffic, and so they time out. Timeout causes the sending gateway to seek an alternative route for the datagram. Routes can be predefined and made static, and alternate routes can be predefined, providing a maximum probability that your datagrams travel via the shortest and fastest route. The application protocols. The following 12 applications were built on top of the TCP/IP protocol suite and are available on most implementations. Simple Network Management Protocol (SNMP). SNMP allows network administrators to collect information about the network. It is a communications protocol for collecting information about devices on the network, including hubs, routers, and bridges. Each piece of information to be collected about a device is defined in a management information base. MIB. SNMP uses UDP to send and receive messages to the network. File Transfer Protocol (FTP). FTP provides a mechanism for single or multiple file transfers between computer systems. When written in lower cases FTP, it is also the name of the client software used to access the FTP server running on the remote host. The FTP package provides all the tools needed to look at files and directories, change to other directories, and transfer text and file binaries from one system to another. FTP uses TCP to actually move the files. Trivial File Transfer Protocol (TFTP). TFTP is a stripped down version of FTP, primarily used to boot diskless workstations and to transfer boot images to and from routers. It uses a reduced feature set, fewer commands, and smaller overall program size. In addition to its reduced size, it also uses UDP instead of TCP, which makes for faster transfer but with less reliability. Simple Mail Transfer Protocol (SMTP). SMTP allows for a simple email service and is responsible for moving messages from one email server to another. The email servers run either Post Office Protocol (POP) or Internet Mail Access Protocol (Imap) to distribute email messages to users. Post Office Protocol (POP) provides a storage mechanism for incoming mail. The latest version of the standard is known as POP3. When a client connects to a POP3 server, all the messages addressed to that client are downloaded. There is no way to download messages selectively. Once the messages are downloaded, the user can delete or modify messages without further interaction with the server. In some locations, POP3 is being replaced by another standard, Imap, Internet Message Access Protocol (Imap). Imap allows users to download mail selectively, look at the message header, download just a part of message, store messages on the email server in a hierarchical structure, and link to documents and Usenet groups. Search commands are also available so that users can locate messages based on their subject, header, or content. Imap has strong authentication features and supports the Kerberos authentication scheme originally developed at MIT. Telnet. Telnet is a terminal emulation package that provides a remote logon to another host over the network. Internet Control Message Protocol (ICMP). ICMP works at the IP network layer level and provides the functions used for network layer management and control. Routers send Icmp messages to respond to undeliverable datagrams by placing an Icmp message in an IP datagram and then sending the datagram back to the original source, the main command used in network troubleshooting. Hypertext Transfer Protocol (HTTP). HTTP is the command and control protocol used to manage communications between a web browser and a web server. When you access a web page on the internet or on a corporate intranet, you see a mixture of text, graphics, and links to other documents or other internet resources. HTTP is the mechanism that opens the related document when you select a link, no matter where the document is actually located. Address resolution (ARP). ARP helps to reference the physical hardware address of a network node to its IP address. Under ARP, a network interface card contains a table known as the address resolution cache that maps logical addresses to the hardware addresses of nodes on the network. When a node needs to send a packet, it first checks the address resolution cache to see if the physical address information is already present. If so, that address is used and network traffic is reduced. Otherwise, a normal ARP request is made to determine the address. Network Time Protocol (NTP), originally developed by Professor David Mills at the University of Delaware, is used to synchronize or set computer clocks to some standard time source, which is usually a nuclear clock. This protocol, along with synchronization utility, keeps all computers on a network set to the same time. Time synchronization is important because many transactions at a time are data stamped in a database, for example. If a time on a server is out of synchronization with the time on two different computers, even just by a few seconds, the server will get confused. For example, one computer can seemingly enter a transaction, but the server will indicate that it has occurred before it actually did. Because this time problem will crash the database server, it is important that these servers and workstations use NTP. User Datagram Protocol. UDP is a transport layer connectionless protocol that does not provide the reliability services available with TCP. UDP gives applications a direct interface with IT and the ability to address a specific application process running on a host via a port number without setting up a connection session. UDP also uses IP to deliver its packets. So here is just a table. So here we have SMTP, FTP, Telnet, Simple Network Management Protocol, TCP, UDP, Icmp, IP Address Resolution Protocol, Media Access, and Transmission Media. So I'm going to leave it here today for this video. If you enjoyed listening, please consider like, sharing, and subscribing. And thank you again.